Welcome to today's video, where we're going to explore an essential concept in compiler design, generating a control flow graph, CFG, and determining which expressions can reach each branch of the CFG. This topic is crucial for anyone interested in programming languages, compiler optimization, or software engineering. In this video, we'll delve into the world of control flow graphs, exploring what they are, how to generate them, and how to determine which expressions can reach specific branches. By the end of this video, you'll have a solid understanding of these fundamental concepts and be able to apply them in your own project. So, let's start with the basics. A control flow graph is a graphical representation of the flow of control within a program. It consists of nodes representing statements or blocks of code connected by edges that represent the possible paths of execution between these nodes. To generate a CFG, we can follow these general steps. First, break down your source code into individual basic blocks, which are sequences of statements with no jumps or labels in between. Then, identify the control flow between these blocks by analyzing the jump instructions, such as if-else statements, loops, and function calls. For each block, determine its predecessors and successors based on the control flow edges. Predecessors are blocks that can potentially execute before a given block, while successors are blocks that can potentially execute after it. Now, let's consider how to determine which expressions can reach a specific branch of the CFG. An expression is said to reach a branch if its result is used in a conditional statement or assignment that affects the control flow at that branch. To identify these reaching expressions, we need to perform a data flow analysis on the CFG.io. This involves propagating information about the values and expressions computed by each block through the graph, taking into account the effects of assignments, conditionals, and function calls. For example, consider a simple if-else statement if x0 else. In this case, the expression x0 reaches both branches of the CFG because its result determines which branch will be taken. Similarly, the expressions ux and z check else also reach their respective branches. So, what are the key points to take away from this discussion? A control flow graph is a graphical representation of the flow of control within a program. To generate a CFG, break down your source code into basic blocks and identify the control flow between them based on jump instructions. Expressions can reach branches if their results are used in conditional statements or assignments that affect control flow at those branches. Data flow analysis is necessary to determine which expressions reach specific branches of the CFG.io. In this video, we've explored the fundamentals of generating a control flow graph and determining which expressions can reach each branch. By understanding these concepts, you'll be better equipped to work with compiler design, optimization techniques, or software engineering projects. If you have any questions about the material covered in this video, please leave them in the comments below. We'd love to hear your feedback and engage in the discussion. Don't forget to like this video and subscribe for more content on programming languages and software engineering.